Welcome to Lucerna Unit 2 Geometry. This is the third video for the Unit 2 review. And in this video I'm looking at numbers 17, 19, 20, and 25. Number 17, on the grid below, graph the location of triangle A prime, B prime, C prime based on the translation. They tell you right here, big important keyword, translation. And remember that a translation is a slide where the triangle is going to face the same direction. This just means it's going to go right, left, up, or down. Now to do that translation, if you look at the notation, for the notation, some people are comfortable with plugging numbers in and the algebra 1 aspect of it. So I'm going to look at this point A to find out where it's going. A is at negative 1, 2, 3, 4, 5, up 2. So this is negative 5, positive 2. Now if you're using this, if you're comfortable with this, all you're doing is you're taking negative 5, plugging it here into x, that becomes negative 5 plus 6. This 2 goes in here for y, 2 plus 1, so this point becomes positive 1, positive 3. Right 1, 1, 2, 3, there's positive 1, positive 3, there's a prime. Now that is definitely one way you can do it. Again, if you're comfortable, if you like plugging in these numbers like that, you can do that also for points B and C. Now if you're using the tracing paper, you can trace it as long as you know what the notation is telling you to do. There's ABC. So I've got this triangle again, it's going to be sliding, it's going to go some direction, and we already know it's going to end up here. But this notation, when you look at this, instead of having to plug it in, you could also look at this and know, well, if I know that this is on the x-axis, positive 6 on the x is going right on the x-axis of direction, positive direction is going to the right. So this is telling me right 6, and this y plus 1 on the y-axis, up and down, plus 1 is a positive move on the y-axis, that's up 1. Positive move on the y goes up. So all three of these points have to follow that same pattern, right 6, up 1. So if I go to this, I go right 6, 1, 2, 3, 4, 5, 6, up 1. There's my new point. Again, notice that I got the same thing algebraically here by plugging those numbers in. Now if you can do that, if you want to deal with points B and C, point B is at negative 2, 1, 2, 3, 4, 5, 6. Oops, negative 2, positive 6. Point C is at negative 2, positive 3. Okay. You can do the same thing. You can plug those in and go from there. Now if you don't want to do that, that's absolutely fine. You can do the same thing as I did with the counting. I can go from point C, 1, 2, 3, 4, 5, 6, up 1. There's the new C prime. From point B, 1, 2, 3, 4, 5, 6, up 1. Point B prime. Now so graph the location. That's my graph. I graphed that triangle after I moved. There's my translation. Right 6, up 1. So I'm done with number 17. Number 19. Now we have a different move. We have this should say triangle W X Y. Reflect, big important word, reflect across this triangle, across the line x equals 1. That is huge. To create W prime X prime Y prime. Now this reflection, when they tell you across this line, usually they say across the x-axis or across the y-axis. But now we have a line. We actually have to graph this line first. So when graphing a line like this equation, x equals some number, it's not a hashtag, it's a number symbol. This tells me the x by itself, that's going to be a vertical line. If it's y equals a number by itself, that's going to be horizontal. If you think about it, the x-axis, what this is really saying is that positive 1 is on the x-axis. It's like an x-intercept. So again, it's a vertical line though, so I've got to actually graph a vertical line. Now I'm going to show, there's my dashed line. I'm going to use a highlighter so it's easier to see. There's the line I'm reflecting over. Now if you're using the tracing paper, you would trace that dashed line, you would trace that triangle, you would flip it over that direction. I'm going to show it without that patty paper. It's always good to learn without the patty paper if you can. Now when you reflect this point Y, that's not going anywhere. Notice it's right on the line of reflection. It's not going to move at all. But point W is 1, 2, 3, 4, 5 spaces, 5 units away from my dashed line, from that line x equals 1. So I'm going to go the same direction on the other side. 1, 2, 3, 4, 5 units. That's where my W prime will end up. X prime, it looks like it's the same distance. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's X prime. Connect. And there's my reflection. Now if we look at just the directions, part A, draw the line of reflection. There's my line of reflection. Part B, reflect W, X, Y, and label its image W prime, X prime, Y prime. W prime, X prime. The only thing, and technically you should put the Y prime here because again, those are both Y's are in the same spot. Part C, state the coordinates of W prime, X prime, Y prime. So let's go. Y prime was right 1. Again, it didn't go anywhere. Right 1, up 1, 2, 3, 4, 5. So Y prime is out positive 1, positive 5. W prime is left 4. Now again, this is from 0. When you're writing these coordinates, you're going from 0. 1, 2, 3, 4. That's negative 4. 1, 2, 3, 4, 5, 6. And then X prime is also negative 4, up 2, positive 2. There's number 19 done with that reflection. Number 20. Number 20 throws a lot of people off because of this word in the beginning. Number 20. If T is the midpoint of SU, that's the big important thing. Find the values of X and ST. This is really finding the length of ST. The diagram is not drawn to scale. Now if it's the midpoint, what that means is, if you think about the first part of that word middle, it means it's exactly in the middle. What that means is that this piece, ST, is equal to this piece, TU. A lot of times when you have the point on, in here it's segment addition postulate, where you're adding parts, you're putting equal to a whole, but we don't know the length of the whole segment. So instead they're just going to be equal parts. They're going to, again, midpoint means this segment and this segment are equal. So my equation I'm actually going to solve is 9x equals 4x plus 25. This 4x is the only variable I have to move. I'm going to subtract it. So I get 5x equals 25. Then I'm going to divide, and I get x equals 5. So right off the bat, you know, look at your 4 answers. The 10s aren't going to work. That says ST equals, it's either going to be 45 or 60. ST is 9x. Plug a 5 in there. Becomes 9 times 5. 9 times 5 is 45. A is my answer. 25, as soon as I find it, will be the last one in this video. Given segment RT, there's RT on the graph, what are 2 of the points that would allow the construction of a segment perpendicular to RT through point T? A lot of things going on in this problem. Now, first of all, they say construction, it's not in this unit, in previous units, you did constructing a segment, constructing an angle bisector. It's nothing like that. It's just trying to get a line that is perpendicular to this segment. Now, the first thing we should be looking at is, for this segment, what is the slope for this segment? And if I draw a slope triangle, I can do that with my highlighter. I have a rise of 2 and a run of 1, 2, 3, 4, 5, 6. So I've got a rise of 2, run of 6, which means my slope is actually 2 over 6, which reduces to 1/3. Now if it's perpendicular, perpendicular means that the 2 lines have to cross at a 90-degree angle, which means also that the slopes are opposite reciprocals. which means that the signs, when they say opposite, that means the signs have to change. One's positive, one's negative. Reciprocal means that it has to flip. So what that's saying is that from t, I have to find some other point that makes this slope opposite and reciprocal. So if I just take that slope of 1/3, I'm going to flip it over. I'm going to make it 3/1. And then I'm going to make it negative. There's my perpendicular slope. So that means from t, I have to follow this slope. I can go down 3, 1, 2, 3, over 1. I can go the opposite direction. I can go instead of -3, up 3, 1, 2, 3, and left 1. I can keep going. I can go down 3, 1, 2, 3, another 1. All these points would make a perpendicular line. So if I connected, I use my ruler. I connected all these. And if I took a protractor and I measured this, that should be 90 degrees. That's what I'm going for. That's what I'm trying to make happen. Now again, it asks for 2 points. I graphed 3 of them. You don't need all 3. This first one I did was right here. That's at 3 and -1, so that's 3, -1. That's my first answer. And then these other 2, I can choose either 1 and 5, +1, +5. There's 2 possible points, 2 possible answers. Now the last part is write the equation of this new line. Use y minus 1 equals m times x minus x1. If I do that, if I use that equation, the slope I got was -3/1, which means it's -3. The first x is going to stay where it is. This first y is going to stay where it is. Now x1, y1 can come from either of these points. So let's say I just go with this one, 1 and 5. -1, there's the 1 going into this x1. -5, there's the 5 going into this. And we want it to be y equals mx plus b form, so I'm going to do this. I'm going to distribute the -3, -3x plus 3. So I'm multiplying these together. Then I'm going to add 5 to get y by itself. -3x plus 8. There's my equation for that new line. Again, remember, big thing, perpendicular slopes are opposite reciprocals. Flipped it over, changed the sign, and I got those points from that slope.